Hello class, welcome to this lecture on object-oriented programming. This is an introduction and an overview of classes and objects that you may have done in your P360 course. There is a document in this week's folder, which is week 2 folder, which contains an introductory example, and I will do two things in this video. I will go over parts of this document to familiarize you with some of the key components of object-oriented programming and classes, and then we will also take a look at the example program that is contained in this document, run it, and see how it works. So the first thing I'd like to point out to you in this video is that the pre-reading material for this is in your textbook, chapter 7, the sections that are given here. Please be sure to read this material because it will go a long way to help you understand the concepts. Object-oriented programming is different from procedural programming. The way to look at the object-oriented world is to see a problem and solve it in terms of what are the entities here and how can I have these entities connect to each other or talk to each other to represent a real life situation. For example, now you and I'm an instructor object and you're a student object, and we interact with each other. I have certain tasks to do. My task is to offer the material and to support you in your learning. And also my task is to conduct exams and to grade you. Your task is to register for the class for which I'm an instructor, and to interact with me via email and do the assigned work. So we in this real world, in the educational world, are two objects, and we are defined in a certain way, and we interact with each other in a certain way. So this is exactly what we would like to do. An object-oriented program is to give a software representation of myself as an instructor and give a software representation of you as students. How to do it is what C++ offers it. It offers us a way to create classes, which are templates. So there would be an instructor template, which defines what an instructor looks like and how an instructor behaves, and a student class, which defines what defines a student, what are the attributes of a student, and what are the actions of a student. This is what object-oriented is about, and also to define how the interactions between the student and the instructor is going to take place. Now, I have taken a very simple example here. This is a very typical example, and you could be working for a company that makes toy dogs. Now, when we represent toy dogs in our program, clearly we have to have a way to represent this in software, right? So your task as a programmer is to take the requirements from the client and say, how can I create a prototype toy dog for my customer so that when they use it, they're able to create software dogs of different kinds and as many as they need, and have them do what they're supposed to be doing. So let's go down in this document and say this kind of specification that is a communication between you and your customer is a UML. The customer does not know programming. You are the coder and the software developer. So you would sit down with your customer and put all of these elements inside a UML, which is the Unified Modeling Language. So as you can see, you talk to the customer and say, hey, what do you want your toy dog to look like? And then the customer is going to say, well, look, I think it needs to have a name, it needs to have a breed, color, and age. This usually comes from the customer because they're paying you to define what their dog needs to look like in the software, right? Who knows? Your program may actually be fed to a 3D printer, which actually creates 3D dogs, or it actually goes into a machine, a robot, which chisels out wooden dogs. So all of this is stuff that is really not kind of our concern, but can become our concern into what is the stuff that my customer wants, and for his final goal, is this kind of thing, is it making sense, for example, right? So some discussion is always good, but here's what you've hammered out: 1, 2, 3, and 4 attributes. And because in programming these attributes need to have certain types, as you can see, you say name is going to be a string, breed is going to be a string, color is going to be a string, but age is going to be an int, right? Because we might need to do some processing on ints. The dog is going to get older, right? So this is stuff that a lot of times, a lot of time, maybe sometimes several weeks or months are spent in designing the UML. Because once the UML is designed, you're going to take this piece of paper and you're going to go off with your software team and write the program, right? So any changes to the UML are best done in the discussion stage, because as you know, it's very hard to change programs. Now that this part in the top area of the UML is the attributes area, right? What is my dog going to look like? The bottom part is what is my dog going to do? These are the functions, right? The most important function here is these two functions right at the top, and then of course all these functions at the bottom. If you notice, there is a plus sign on all of these here, right? And this plus sign indicates that all of the behaviors of your toy dog, they need to be public. People need to see the dog, right? However, if you notice at the top part where you have the attributes, you have a minus sign here, which means all the data related to the dog needs to be under the hood, right? You as a customer, when you buy a car, you're not expected to open the hood of the car and mess with the wires. So there's a lid to all of that. So you don't want to see any parts of the car except the wheels, the steering wheel, and the gas tank, and the seats, and so on and so forth. Exactly. So the engine, and everything under the hood is hidden, it's private. That's what this minus means. Now, when we come here to the behavior, there are two methods called dog. These are actual methods, but you see they are special methods in that they do not have a return type, right? So it just says dog here and no parameters. And this one says dog with parameters. The dog without, so these two methods are called constructors, because what C++ does is that when you ask for a toy dog to be created out of this template, then C++ is going to go to the factory, as it were, the dog factory, and create a toy dog with the specifications, initial factory settings or the initial specifications that are given. Now, if you call this constructor dog without parameters, then you're going to have the basic factory setting. Who knows, it might be a dog with a blank name and a gray colored dog, and the breed is also unknown, right? So if the customer is not careful or doesn't want to be particular, then they can just create a dog with default specifications. So but oftentimes when the customer would like to create a dog, then they would like to give it a name, they would like to set a breed color, and also set the age of the dog, right? So that's what the regular constructor, the second one, is doing here. As you can see, this says regular constructor here and default constructor on the top. The next four, 1, 2, 3, 4, are getters. There's another word in your book for this. These are called accessors. The word getter is more common and familiar. And for every attribute that you have, you see name, breed, color, and age, you have a function that actually returns to the client the current value of what's in these variables. So a get name is going to return a string that contains the current name of the dog. You might later on sell the dog and someone else might give it a new name. So what is the current name of the dog? What's the current color of the dog? What's the current age? And so on, right? So these getters are important because you have hidden everything under the hood. These getters are like dials or displays on your car dashboard, which tell you how much gas is in the tank. There's a difference between you having access to the gas tank and taking a peek into it and then setting up a meter or poking something into it to see how much gas there is, versus you looking at the dial on your dashboard to figure out whether your gas is empty, your tank is empty or full, or what stage it is in. Correct? So exactly in the same way, getters are like the dials on your dog, which show, right, what is the name, what is the age, what's the color, and what the things, without going into and examining the contents of the dog itself, right? And then the setters are those methods that allow you to change the attributes of the dog. Exactly. For example, you do not mess with the engine, But if you would, but you can see the speed of the car as you drive. If you would like to see the speed of the car, you look at the speedometer. But if you'd like to change the speed of the car, you can do that by using your brake or your accelerator. The setters are like your brake and accelerator. They help you change certain things about your object. And in this case, the setters help you change the name and so on. Remember that setters are privileged functions that allow you to actually change things, right? And there may be occasions where you're not given a setter. Now, the other methods that you see here are the getters and setters are typically going to be there for any class that you create. Dogs, cats, monkeys, ships, right? Anything, furniture, anything that you create. These are common. But the methods that come here, the eat, bark, go for a walk, and all of that are specific to the dog. This is stuff that you decided with the customer. What would you like your dog to do? You'd like your dog to eat, you'd like your dog to bark, go for a walk, and toString. This toString method, I know I had a lot of questions about toString. This toString method is usually very, again, common to every class because an object consists of many attributes. And you would like to have, for example, a way to display in your client program a snapshot of what this dog looks like, right? So this toString method is a string that takes all of the attributes of the dog and returns a string in whatever form the customer would like, right? And returns it to the client program. Now you see here this toString method should return a string consisting of name, breed, color, and a string consisting of the age. So if you want to convert all of this into a string, you're going to have to find a way of using a to_string method in C++ to convert integer to string, right? So just bear that in mind. Now, once you've done with all of that, I'm going to, you see the dog. So I've written my dog program here. Instead of inspecting this code, I'd just like for us to go to my IDE where I can show you how I have written this. Now, as you can see here, you are looking at my method called main.cpp. If you were, and this is the client program that creates dogs. This is also the reason why we practiced in the previous weeks the 3-file business, because when you start to write classes and objects, you need to put the class specification file in one place, the class implementation file in another place, and the client file in the third place. Now, the way my IDE is defined is, I'm not able to rename this for some reason, but in your programs, this would be called, this one would be called dog main, and this one would be called dog functions.cpp, for example, and this one would be called, let's call this dog header, right? Dog header.h. And now here I've got to change this to dog header.h, and then I go into my functions file and I change this also to dog header.h, right? So now I'm just going to run this program just to make sure that it all hangs together after this change, and yes. So I would like us to go first to the dog header file. This is your class specification file. Here is where you put all of your include statements. Whatever C++ libraries you would like to use in your program, this is the place to include them. You do not need to include them again in any other file, right? Now here, you see, the minus has become private. I've converted that UML diagram. Keep in mind, this was the UML diagram, and I'm using this UML diagram. It's right here. I'm using this UML diagram, this part, right? I'm using this. This is the part that I'm doing here, private, creating these variables as private, and then giving the function prototypes in my header file. So when you need to write classes, you need to pick up your UML and just word for word work exactly as per the specifications. So I'm going to go back here. So, and you will see all the methods and all the declarations in my UML are going to find a way into my specification header file. So here it is, private name, age, color, and breed. And if int age had come last, the order doesn't matter, but we still need to be consistent. So I'm just changing that. And here we go. Now, public is where you have the plus sign. As you can see, regular constructor, default constructor, and all of the getters, setters, and methods are here. Now, know that these are prototypes. I haven't done the method function definition yet. Where should I do it? I should do it in my functions file. So I go here, I include dog header, and here is my default constructor that gives a value, a default value to my dog. So if the customer does not give any values, then this is the kind of dog that's going to come out of the dog toy factory. And then here is my regular constructor that takes the incoming values, right, and sets these attributes to whatever the client has specified. So name becomes my name, age becomes my age, color becomes my color, and breed becomes my breed. A preferred way to do this, rather than juggle 50,000 parameter names, is this is your attribute. You want to set it to the incoming attribute. But if you do name here, then that's confusing. Which name is going to get, what do you mean by name equals to name? The parameter is going to be set to the current attribute, or the current attribute is going to be set to the parameter. So what we say is this dot name equals name, where this is refers to this object. So when you read your book and you see, oh, it's a pointer. So when you read, usually you're able to do this dot name or this arrow name, and when we come to pointers, the difference will be evident to you, right? And so this is a kind of little bit of a diversion into what is the meaning of this. It refers to the current object. But I'm going to go back and just keep to name is equal to my name, right? And say, let's call this my name, right? So this is going to, my name is going to get set to my name, ages, and so on. So now you've actually given the factory some specifications for creating your dog. And these are getters, as you can see, are very simple. They return the current value of age, color, name, and so on. And setters set the values. You see the toString object? It says return I am a name, I am a and I am a whatever age dog. The one thing that I wanted to point out is on the G++ compiler, when you do standard toString, it does not recognize it. I'm just going to type out something here that you might need to do when you compile it, is G++ minus std, right, equals C++ 11, and then do dog main dot cpp, and then dog header dot age, and of course you can do minus C here just to compile that, or we can just compile and link it together and say dog functions dot cpp and minus o dog, right, dog program. So this minus standard equal to C++ 11 will solve any compiler errors that you're likely to get here. And I'm just going to put this in comments here for you to see when, all right, right? So in case toString gives compile time issues, right? Okay, So now I'm going to go to my main program, and as you can see here, I have created a dog called MyDog1. I have not, if you do this, you will likely to get a compile time error. The way to call the default constructor is not to give anything. The way to call the regular constructor is to actually give those parameters. So here I'm just creating dog1 with the default and dog2 with the regular parameters. So my dog1 really doesn't have a name, and dog2 is given a name, it's given an age, it's given a color, and it's given a breed. And all I'm doing is using the toString method, because I know that the toString method is going to return a string to me, and I can print that. Another thing I wanted to point out is I'm creating the dog here, and I'm calling methods. I'm calling methods by using the dog variable name followed by the dot. The dot is a signal to C++ that you would like to access all the methods that you created in your functions and in your header file. So for example, you can do mydog1.toString.getBreed, .getName, .setAge, and so on and so forth. And that's exactly what I'm doing here, right? So when I run this program, right, here's the output. Here's the output that I'm getting. As you can see, the first one says I'm a doggy, I'm a 1-year-old white dog. This was the default setting. And the second one says I'm Linda, I'm a 7-year-old white dog. And then you go ahead and change the age of Linda the dog to 99, and then that's what it is printing. I can very well make Linda a black dog. Why not? And then let's run this and see. You see, now Linda has become a black dog. So this is an overview of classes and objects, and I'm going to ask you